Alright, it's time to explain the problems in LeetCode Biweekly Contest 26. I did not do very well in this contest. In fact, I got rank 3000 because I didn't solve the fourth problem in time because, I'm not smart. But also, I started this contest about 10 minutes late because I did not wake up early enough. I woke up 5 minutes before the contest, so I ended up being about 10 minutes late. Let's explain the problems. Problem 1. Consecutive characters. Given a string S, the power of the string is the maximum length of a non-empty substring that contains only one unique character. Return the power of the string. So, this is pretty simple. We're just trying to find the maximum length of any consecutive characters. For example, in LeetCode, that would be 2 because there's 2 E's. And in this string, that would be 5 because there's 5 E's. And this is pretty easy because we can first say... set the default maximum value, which is 1, because there's always going to be at least one character here. And then we keep track of like a sliding window. Basically, we keep track of the first digit that is the start of the consecutive substring, and then we find the end, and then we max that with the current max, and then we continue from there. So this is linear time, and I don't know. Okay, problem 2, simplified fractions. Given an integer n, return a list of all simplified fractions between 0 and 1 such that the denominator is less than or equal to n. The fractions can be in any order. Basically here, we can just bash. We are looking at all the fractions with denominator less than or equal to n, so we just do that. And then for each denominator, we consider each numerator. If the numerator and denominator have a greatest common divisor of exactly 1, that means the fraction cannot be simplified. So we can just add that. And then at the end, we just return the entire list. This is not very difficult. Problem 3, count good nodes in a binary tree. Given a binary tree, a node is called good if the path from the root to that node does not contain any nodes with a value greater than x, or the node. return the number of good nodes in the binary tree. Basically, we do a simple depth first search, and we also carry a parameter with the node that we're currently searching, and that is the maximum value of all the nodes that have been seen up to this node. For example, if we're looking at 3, this 3 over here, then the maximum value would be 3. And to compute this, we can just do a simple max. We just max the current parameter with the current node's value. And if the node's value is greater than all the nodes that have come along this path, then we know this node is good, and we can just add 1. Yeah, this is pretty simple. It's just a variation on DFS, I guess. Yeah, it's not too hard. Problem 4. Form largest integer with digits that add up to target. Given an integer array, cost, and an integer target, return the maximum integer you can paint under the following rules. The cost of painting a digit is given by cost. The total cost used must be equal to target, and integer does not have digit 0. If there's no way to paint the integer, return 0. This is actually just a simple dynamic programming. I did not figure this out during the contest. In fact, I tried something way more complicated than this, but it doesn't require anything harder than this. Basically, the DP state is given by the number of integers we've used, so the number of digits we have chosen to use so far, which can go up from 0 to 9, I guess, non-inclusive of 9, and the other one is the target value. So we make a big 2D table. The columns are labeled by the target value, and the rows are labeled by the digit. And then basically, the transition is we take a look at all the possible digits that we can add. We take away those costs, and we look at the DP table value for that cost, and then we see the new number, and we want to find the maximum of this number. So we just max it out with whatever value was there before, because we can probably form it in many different ways, given the target value and the digits. And at the very end, we just see if we can form this number at all. If it's -1, that means there wasn't any way to form it. But otherwise, we can actually find a number. And the key to this is that Python can handle very big numbers. Like, it can handle numbers like very big numbers. Like, yeah, it can handle very big numbers. So that's the key to the problem. Otherwise, you'd have to do some kind of backtracking, which is what I tried first, but you don't actually have to do that. So yeah, I think that's all for Biweekly Contest 26. This was a bad contest for me because I didn't finish all the problems, and I got a few bugs on early problems. For example, problem 1. Oh yeah, some edge cases. I got the edge case where all the consecutive strings are at the end, and if it's just a single character. So I got those for 2 bugs. Problem 3. What did I get wrong? Actually, what did I get wrong with this one? I don't know. Oh yeah, okay. I accidentally clicked submit when I hadn't like fixed all the errors yet. So yeah, that was an accident. I should not have gone that. But like getting 3 problems is not a very good score for me. Maybe I could have finished the 4th problem if I was a bit smarter, but you know, I just wasn't smart enough, and I didn't have enough time this morning because I started late. But I also solved it after 10 minutes after the contest actually ended, which probably means I couldn't have solved it within the contest anyways. So maybe this was just a harder contest for me. Yeah, I hope you enjoyed the video. If you have feedback for my explanations, please leave it in the comments below. And I'll see you later today in the weekly contest, 189. Thank you.